Welcome to session 2. So today we will go over some basics because we had a couple of high schoolers and unfortunately today they had an overlapping meeting and I was informed yesterday. So I'll be recording the session with them in the point of view and we will talk about several things. So I'll skip the introduction, but anybody who wants to look at the agenda, this is the agenda. And if you are in this call and have not taken this survey, please take the survey, just take a screenshot of this and take the survey after the session. So let's go over the basic, but let me see first if I can swap my screens. I think there's a better view. Yeah, so let's go over like very basics that today we will go over using on demand. So the current screen is actually showing a particular instance of how you would actually look at any supercomputing center, which is like a very generic overview. You as a user, you will use a login node to log in into the entire ecosystem. And then from there on, if you want to do heavy computing, you'll ask for compute resources and execute, or you'll use some file interface like say Visual Studio Code or on demand, or even simply your command line to log in into your file server and look at your shared file systems. So you could look at this entire box as your laptop, where this is like you're putting in your login request and then you're looking into your file system directly. And then from then on, if you want to run your job, it automatically uses your CPU to run your job. Just a second. Okay. Someone was trying to log in, so just give me a second. Okay. So today we will quickly go over what OSE or tag, whichever resources you have access to, if you can interact with them and how you'll interact with them in batch mode, which is command line, or interactive mode using Visual Studio or on demand. So let's quickly go into the details. Like last week, I have provided a couple of training materials to go over, which is like how to use there are a couple of resources, but essentially like what is a batch system in OSE, how do you interact with OSE, and those free training materials. And these are really good training materials, so I encourage everybody to do them if they have not done already. And now let's go back into our on-demand scenario. And I believe everybody on this call actually has used on-demand once in their life. So I'll still go over it for others who will be looking at this recording later on. So this is how your on-demand dashboard would look like as soon as you log in into the system. So it's ondemand.ose.edu. Once you log in there, you will see you have several options, like you have files, your jobs, different clusters that OSE has, and different interactive apps, like here, different kinds. You can literally request a desktop version to any of those compute nodes that you have seen, or the login node from login node. But today we will look over the Jupyter Labs, which is super essential when we're doing AI workloads. So let's go back and look at the file system. So this is one way. So here I'm looking at files. So these are the different file systems or file spaces that I have access to. If we can quickly go back to this diagram, the file systems that I have access to are these disk spaces. So inside these disk spaces, it's like how you have your folder structure. For instance, in your laptop, you'll have a different folder structure, let's say desktop, recents, documents, and different paths, right? So similarly, you'll have different paths on systems like OSE, and these are the different files that I, as a user, have access to. And today I'm choosing to go to this particular folder. And here is where I'm actually looking at different files that are available on my system. And other way to look at these files is use a terminal. So here, if you see on the top, you have access to different kinds of terminals. Like different clusters, you can use the login node of different clusters to make it feel as if it's like your command line prompt. So I'm here with, again, the same project space that you look here, same project space. But now instead of using or viewing that in GUI, you'll be looking at it using command line. And you can type scripts, type commands like ls, ls-lah, and do other file operations here using as if it's just a command line interface. So that's one way. Another way, if you don't want to use, let's say, your browser, you can also go to your terminal. And then you could simply say SSH, your username, whatever is your on-demand username, because on-demand needs, or whatever is your OSC username. And you say @pitsr.osc.edu. And you ask for your password. And you are in the login node. So here you see you are in the login node, and you can do here, if you type this, you'll see a different folder structure than what we saw, because this is your home directory. Like if you literally type echo $home, you would see the path to your home directory, which you can also see from your on-demand browser using files and home directory here. If you click files and home directory, you literally reach the same one. So now if you want to go here, so I was just copy pasting this project space, ESS project space, and I could literally say CD here. Yeah, it starts with a / like root. So now we will see the same folder structure that you have been seeing previously in the previous screen. So this is one way. And the third way of interacting with the system is your Visual Studio, which I'll talk about in a while, but first let's wrap over the on-demand version. So here is the on-demand way of accessing the file systems and playing around with the files. You can create like new directory from UI, or you can create a new file from here. You can refresh a file, you can upload. For instance, let's say you have a bunch of files on your local box, you can upload them, you can download them, or you can create a Globus instance, which we will be covering over the upcoming sessions, which is pretty useful if you're trying to transfer huge amounts of files, especially for AI or machine learning training into your OSC system. So I'll go over that in session 3, but yeah. And you can do copy, paste, move, delete, and all those using just this line. Or if you're comfortable with command line options like CP, RM, you can use the command line option. So now going into the third option, here you see I'm already connected to a remote instance. So let's first terminate that. Like I'll just close the session. And these are several SSH sessions that I have connected to in my system, but you can go click. If you don't have Visual Studio, please go ahead and download Visual Studio. But yeah, so click SSH session and you can create a new session here. I'll say again the same command that you have used for terminal. It's SSH @edu. Oh, sorry, I mistyped. Same, so you'll do a remote cell. I'm configuring it. And I'm connecting. I'll say connect. So now I've like literally a config gets copy pasted. Now it's asking you for, once you click connect, it'll ask you for your password. So I think Pixar doesn't support Visual Studio, so we might have to go to another cluster. And I've tried this morning and it had the same issue. So now instead of Pixar, let's do another remote session, which is Owens. The same thing, Ascent, there's another cluster that you can try, SSH. Ascent.osc.edu. Shell config. So connect, click on connect, and it's literally taking me to my login page, which is on Ascent. And then I'm already in my login node, and here, if I click my terminal here and see, since it's connecting to your login node as like a terminal option, you see that you are in your Ascent login node here. So here, if I type ls, I'll literally see my home directly. Like echo, I can echo $home, and I can see that I'm in my home directory. The same steps that I've taken using the terminal. I could do cd fs ess pas 227, I think 271. Yeah, I'm in my project space and I see the same folders that I've been seeing previously. So this is like the 3 different ways, and there are several other ways of you can connect to OSC, but I feel that these are the three most useful ways in which you can utilize OSE more efficiently. Any questions so far? Let me open my chat on the side. If you have any questions, please feel free to stop me anytime and ask the questions. And please feel free to follow along as well. Especially if you have not used OSE before, please feel free to follow along. And then here comes the tip 1. Since now you have seen, so before going to tip 1, I would want to emphasize 3 different kinds of folders that we have at OSE. So if we actually go and look at osce.edu and we look at Pitzer. Oh, Pitzer is having an upgrade. So if you look at Pitzer cluster, here you see 3 kinds of storage. You see home, project, and scratch. And each of these directories or each of these paths have their own functionality. Like home is like your own personal space, which is super private. So let's say I create a folder here in my home directory. All these, I can never share it with anybody. So I can't give like chmod privileges to some other user to come and use it. For instance, like let's say me and Gautam on this call want to share some code. I should never be placing it in home directory because it's super private space and it shouldn't be shared with anybody that's not you. But then you have other spaces, which is ESS is nothing but the project space. For instance, let's say you're working with Dr. Rajiv's lab, then you can create something like here, like for example, 911 data set that we have created, but many other people would use it. So if I want Gautam to use it, all I have to do is go to this folder directory and change chmod, like change privileges or share this like you share a Google Drive and you can use it because this is project space. And then you have another space called scratch space. Here you see the project PS2271 also has a scratch space. So in this scratch space, you can also do a ton of things, like you can share files, you can run your code. But the key differences between project space and scratch space and home space is that, as I said, home space is super personal. It's your personal space and it looks like this. So every user will have users and whichever project that gave you access to OSE before. Some people might have access to PS2271 first, so you'll have PS2271. And this is the right time to paste your home directories, like type echo $home and whatever you get, paste it in the chat so I get to know what different users you are from and how it helps. If you can, like we can see. So essentially, whichever project you're assigned to, inside that project, it'll be your user space name. And up until yesterday, for instance, like even I'm learning, constantly learning. For instance, if I actually go back to my on-demand homepage, here I see a quota warning, which says literally users inside my project, like PS0536, has achieved its quota limit. But essentially what this is trying to say is the project space, which is /users/PS0536/SwathiVM, which is my personal space, has reached the quota limit. Not all the files that are within this project space. So we try to reach out to Ohio Tech and ask, hey, this is the case. Can you delete a couple of users that are no longer with our project, like maybe 10 years ago? And they said that this warning is not for everybody. It's for only me, though this message is super not clear. So sometimes it's still learning for me as well. So don't get overwhelmed if you don't know anything about OSE. You'll learn eventually. So on that note, so this is my home directory. As you see, this is my project space and this is my name. Whereas Scratch also has the same project structure, but FSESS means it's project, FS Scratch means it's Scratch space. Those are the 3 directories. And coming to the key differences between project and Scratch spaces, project space sometimes will have like 5 TB or 8 TB limitations, and project space is more expensive space because you'll have persistent memory. For instance, let's say I copied a code today into my project space, I can come back 10 years down the lane and still that code would be there. Nobody would delete that until my project manager decides to delete that particular folder from project, because whoever owns the project pays for that space. So it's like persistent and consistent until manually you delete it. So it's a very secure storage. So this is the place where you can store your more permanent data sets before, let's say, pushing out to Hugging Face or pushing out to Kaggle. If you want some internal storage, this could be used. But again, disclaimer, it depends on how much your project is paying to OSE to make the storage happen. So initially, I think they give 1 TB, then you extend. We extend it for 5 TB and we still overuse it. Whereas coming to scratch space, in theory, it's unlimited. But then if you, let's say I wrote a code today and I didn't touch it for the next 60 or 90 days. I think they have a 60 or 90-day limit. If I don't touch it, they'll delete that folder. So every time they clean up the space and look at what are the files that are not touched in beyond the last 60 or 90 days, and they delete that space. So scratch space is really useful when you have like tremendous amount of data and files that can't fit your project space, because project space is not only about the file limit, it's also about how many files you can copy. For instance, let's say I have like 1 KB files versus a 1 TB files. It's still the same because they have still a limit on how many number of files you can store in your project space, because it's all logistics about listing and other logistics. So if you have more, let's say you have big files, then you can go for scratch space. Or if you have more number of files, even if it's like say 1 GB, but you have a million files inside 1 GB, then I would say use scratch space because it has no constraints of space and time. The only constraint is it gets deleted if you're not using those files. So it's wise that you start using scratch space, like put your projects, test folders there. And once you have something concrete, move your important code into project space. And if you feel something is even more important, like your personal, which you like, say, maybe some important code for your thesis or thesis documents, you can move it to home directory. But home directory has extremely tight limits on how many files you can store. So they'll give you like 100K files, and I'll eventually will tell why you shouldn't use home directory for any of your coding purposes. So that's step one, and it's very important, especially when you're using any supercomputing center, knowing the differences between home directory, project space, and scratch space. And we'll come back to scratch space when we are also talking about compute nodes, because apart from scratch space being here, there's some sort of scratch space inside your compute nodes. And if you copy code there before running it, it'll be like super fast, especially if you're copying your training data into that space. And we'll talk about that eventually. Any questions so far? You can put in the chat. I have access to chat as well. Or you can raise your hand, unmute yourself and ask. Okay, so let's move on to the next one. So today we'll talk about environment setup. And as I know, I think many people in this call already use environments when we use OSE before, but I'll briefly go over for our undergrad and high schoolers so they'll know what an environment is and why they have to use it. So imagine environment is like your home room space which is movable. So first you want to create a nice environment where you can run your code, where you have more access and control to what and how you do it. Let's say you can't, maybe you're living in a dorm, and you share your dorm space like me. Then you can only decorate your side of the dorm, but not the other side. And when you're changing rooms, you have to efficiently decorate your room so you can swap easily. So packaging works similarly when you're working in environment. So it will help you for package isolation. So let's say you're running one model for vision models, like say computer vision, object detection, and you are running another model for another class on text. These two might require different environments. One you're running on PyTorch, one you're running on TensorFlow, or one you're using convolutional nets and you apply Keras convolutional nets. On the other, you might be installing BERT models. So it's always advisable that you maintain the space separately. So when you're running vision model, you have more access to the packages that are required for vision model, and so on. And also the dependent, it's easy. For instance, if you want to run a very old code that is like say 10-year-old code, then you might need to use TensorFlow version 1 as opposed to version 2. But if you use your home space to create all environments like universal home space, then you won't be able to do the switch easily. So it's always advisable you have independent environments for independent projects that you create. Then B is obviously reproducibility. Like you're writing a paper today, then maybe the paper gets submitted and people want to download and test your code, let's say 3 months down the lane. Then you can simply export your environment that you created and share that along with your files and your Git repo. So people can see what version dependencies are there before, installing with the latest version, let's say 3 months down the lane, and say the code is not working. So it is very smooth for transition for reproducibility. And today in in the next coming examples, we will see how we will be implementing package isolation, reproducibility, and all in a couple of examples. Then the next thing that we try, which is useful for environment setup, is again breaking system. Sometimes you might need, so you need home privileges. I mean, you can't on systems like OSC, which is like shared system. It's not like your local laptop, so you can't have admin control. So you can't have root privileges and stuff like that. So it's a nice environment where once you create that environment, you can literally install any software you want inside that environment and play around with it. So it's like your cool, nice sandbox that you can play around with without having to touch the global sites or global packages. For instance, if I actually go back to my home space, you will see a ton of Python files here, which are essential to run your system, like maybe start your system, set up environments, but it may not be important to run your specific code. So same like I think in Windows, you call it the C directory and the D directory, right? On that note, my sister once said her system was like overwhelmed and she doesn't have any space. So my mom said, delete some files. So she literally deleted C directory and D directory, and her system wasn't loading because all the softwares needed to load the system were gone. So similarly, all the softwares that are super essential for you to set up environments and stuff stay in your home directory. But any software that needs to be project specific can go into your project space or scratch space, depending on how long you need it. So downloads, it almost looks like your home directory, right? It has desktop documents. So whenever you try to use these desktop options, for instance, like interactive apps, any interactive apps like Jupyter Labs, your desktop, it actually goes into this space and makes it create as if this is your local system. So that's how home directory is important. So you won't touch global sites or global packages that might actually tamper how you log in into OSC. So having a Python environment that is in your project space, you can play around and literally break your code, try different versions of Python, try deleting sites that, I mean, packages that you have installed and everything safely inside an environment without having to touch the global site or global packages. Then again, one more thing is, as I said, reiterating, you don't need admin privileges and you can use non-standard packages. Like for instance, we are developing ICICLE UCA components. So I can go ahead and happily test the components on OSC, installing from SDK without having to worry about what if this violates some code or there's some data breach or some violation. So any non-standard package I can still try because it's within the environment that I create. Yeah, there'll be still more violations, like maybe if we don't do security tests, that's another thing. But this is not going to go ahead and, modify your home directory or global site spaces. So it's more free. It gives you liberty as a researcher or an as a student to play around with software and software packages. And let's see. Yeah, I think this is very cool, which is I try it every time, which is Python version management. I'm still using like Python 3.10 to test many of the YOLO models that I do, which is I think one of these stable versions. But I think we are on Python 3.14. And sometimes if you actually type what Python version you have in the command line saying Python, each system actually has some default version that is installed. For instance, here it's 10.3.15. But now let's see what is this login node. It's also, I mean, in theory, we should have the same, but let's see. Yeah. So now let's try ascend here and say, oh, it's nice. All of these has the same thing, but when I actually tried logging into one of the compute nodes, it has 3.13 as opposed to 3.10, and we'll see that again. So any discrepancies, others, is everybody seeing 3.10? Sometimes different users will have different Python versions visible based on what modules they loaded. Gautam, what version do you see?
Swathi, even I'm still checking. Not yet. I'll once check and let you know.
Anybody else, any different versions? Otherwise, fine, we'll move ahead. But basically, you will need different versions. This is a stable version, but you can also see module Spider, Python, and you can see all the versions that they support. I think I might have mistyped something. This is perfect. Okay. Spider. Kuda, that should work. Or I might be mistyping something now. So let's see, module. Spider. Kuda. Yeah, I think I might have mistyped something, but Python. If you just type this, you'll see different versions that they support. And here with the examples that they give, it's not limited to just this because you don't see 3.10, but you'll have many versions. So that's one of the beauty of setting up your own environment. So even let's say the system only has until 3.9, but if you want to work with 3.10, 3.11, 3.12, you can set up your own environment in Conda and say, hey, I want a Python 3.10. And 3.10 will be literally installed inside your environment, which is my environment. And we'll see that in a couple of minutes. So it's really cool. So even if OSE doesn't support a certain version of Python, you could still use maybe even the non-standard versions of Python inside your Conda environment, even if OSE is not supporting, because literally you're not changing your home directory, but getting a copy of it into your project space. So without further ado, let's go into Conda installation. And if you want to do it simultaneously with me, more than welcome. But I already have a couple of environments, but I'll still try and do it for you. So I would say this is my, if you actually see, this is my project space. So let me go to my space and inside this project space, because this is ICICLE project space and many people use it. So I have my own folder. And this is another tip I would give you. Like if you are part of any projects, just don't randomly create like say temp test folders inside this, because people will not know what that is and they'll delete it. So it's always advisable that you have your name within the project space that you're creating, so nobody else will touch your files. I mean, obviously I can't delete your file and you can't delete my file, but an admin can delete it thinking it's useless file because A, there's file count limitation, and B, there's file size limitation. So be responsible in choosing what name you put so others will know who is using it and they'll not delete it. So inside this, let me make I think I have a class here. Yeah, for today's session, I created a folder. So CD OSE session 2. And let me create another one called demo. And I'll now go into demo. And here is where I'm basically downloading. So basically with this particular command, I'm downloading the information, and let me put that command in the chat for you guys. So simultaneously, if you want to use, you could use it. But if you want, let's say a Conda environment, not for your Linux box, but for your Mac OS or Windows OS, you can go into Conda, literally do a wget here and choose which system you want. So they have like tons of packages. You can choose between the older versions and the newer ones, but I would always use latest because that's more stable version of Mini Conda that they have. And you have Windows, Linux, and Mac OS options. So whichever operating systems you use it. And I mean, I will share I'm guilty when I install softwares on my local box, I don't use environments, which is crazy because 90% of the time I use OSE to do development. So, but I would still strongly recommend if you want to use environments on your local box, you could use it. So now if I actually look at it, I have a Python file. So now all I have to do is bash miniconda hyphen, I think if I'm not wrong, -b -p, and you just have to give a path. So $pwd is present working directory and miniconda3. So I'm literally extracting and running it, and I'm storing the entire miniconda files in my local directory. And if you don't want to install this, there are other ways to do it. If you actually go to ose.edu and type miniconda, and then, oh, sorry, mistype. So if you type miniconda, you can also use the Conda environment that they give you as modules. So another tip is OSU has like ton of modules. So if you can, let's say, go to any of your login directory and see, use this one called module list and maybe grep conda, or wait, I forgot what was the command. So module list will literally show you all the modules that you have. Module spider, conda will give you all the conda environments that they have. So you can literally choose whatever you want, and you can say module load mini conda and select that version instead of downloading it. But when you're doing this, you're literally creating an environment in your home directory, which is fine as long as you don't have many files, or you're not installing many softwares and you're just doing simple Python or pandas. But if you really have, let's say, Ultralytics or llama models or any other software stack, I would strongly recommend against this, because you don't want to store all those environments in your home directory, which only has like 100K file limit, which would not be sufficient. And I tried it and I couldn't go beyond one environment in my home directory, and hence you see errors like you have seen, like file quota reached errors. So I mean, the installation is pretty quick and done. Now if you see, you literally have a mini conda environment here. So all the next step is to set up. So once you have your mini conda, you can use this mini conda to set your environment. So here comes, I think, step 2. So before making any installations, for example, if you're installing Ultralytics, what Ultralytics does is it looks into your hardware. For instance, if you're installing Ultralytics on your laptop, which is like say Mac OS, it looks at the underlying hardware and tries to install packages or dependencies, hardware dependencies, CUDA dependencies, any dependencies that it needs by looking at the hardware of the system. So if you are in your login node like this and you're trying to install a software, I would strongly advise you not to do it. First, get an allocation, then do an installation. So before I tell you what are the different allocations, I'll give you a command. Just use that command to first get an instance of GPU. If you want to do a CPU installation, login node is fine because login node has CPU there, but otherwise it's always advisable that you get an allocation and then do the installation. So I have the list of commands as one file. Let me quickly share that with you. So file computer. Yeah. So I'm putting a list of README files that look like this. So you see all the setup code, commands, and all the commands that I'm using right now are listed here if you want for reference. So here I'm just taking this particular script here, and this one literally is asking for 10 cores. Like I need one node, 10 CPU cores, and one GPU. And I'm using PS2271, which is like the ICICLE project. So for this resource, I'll be built for this particular project. And I'm asking for 2 hours, I mean, which is less than the session, but I'm asking for that. And now so don't copy the $ like I did. It's only to indicate that we are in command line. So go ahead and ask for a resource. It'll take a little while, but I would strongly advise, like if you are doing GPU installations, please follow by this. And I could quickly show how Ultralytics deduces that. So this is one of the Ultralytics installations. So initially, like when you say install Ultralytics, so this particular line, this particular installation setup would look at your underlying hardware and install every dependency. Like here, for instance, it will be when I'm using this command on my local box, it will literally look at stable version Mac, pip, Python, and default, and it uses this installation of Torch. But if I have a Conda environment, say I have loaded, I'm literally in a Linux box, and I need a pip installation with Python, and I have CUDA 11.8 installed, then you see this being changed. So Ultralytics underlying would actually figure these things out. So installing from the configuration of the system that you want to run on is more recommended. Otherwise, you can go and change paths and stuff, which is more tedious. So now coming back, earlier we saw login node, but now we see P0231, which is essentially this node that we are here. One of these nodes is named P0231, and we are inside that node at this point. And this particular mode is called the interaction mode, where you are literally treating that node as your own local box, and you're inside that, and you can do all the operations like ls and stuff. So now inside this path, the next step that I would do is, first I know where my conda is. Now I have to tell my system, hey, instead of using home directory, use the conda environment that I have installed. So for that, what you have to do is, let me quickly go to that slide. Yeah. So once you have gotten the allocation and stuff, so you have to say, hey, conda, now instead of loading from the global mini conda or the default mini conda, load from my source. So this is the old space that I kept, but now let me look at my current space, pwd. You could literally say something like this. So this is super tedious, but I'd rather, let's say, $pwd here, which is current working directory. And I'm like sourcing it. So here now it's taking whatever is the new mini conda that I've installed and it's activating that environment. So from now on, whichever installation environment that you do literally gets stored inside the mini conda, inside your project space and not your home space anymore. So this is, I mean, you have to redo it every time you do a setup, or you can globally change, but I would advise not globally changing and redo it or put this every time you do, as it's more safe. So essentially what this does is it activates your base conda environment, sets the path. Like most of us know what a path is, right? A path is nothing but a semicolon separated list of all executables, where let's say your Python, your Java, all the executables get stored. And when you say Python test.py, your operating system literally looks where the Python exists inside your entire path and runs that particular Python. For instance, I have Python 10 and 9 both in my path, and I have Python 10 coming first in the list and 9 second, it will run Python 10. So something like that. So it will try to search the path for your executables, and conda sourcing it is literally putting your conda environment into the path operating system environment variable. And the next thing that you have to do is export Python, and you have to do this only while installing. So export Python user site. What this does is it will tell your installer whenever you're doing, say, pip install torch, pip install ultralytics, it says exclusively that do not install anything outside this conda environment. Like, don't use my local source, that is site packages that exist in my home directory. Strictly use this one. So this is the next step, and you don't need to do it when you're using conda environment, but you need to do this when you're setting up the conda environment. I've learned that the hard way. So I set this up. So now I'm ready. So now I have my conda source ready. Now I'm ready to set up my own environment. So if you see, I can literally set up my environment, conda create YOLO, and this is the one I'm saying. So what I'll do is to speed up the process, I'll use multiple screens to do the same thing. So here I'm saying this is command line option, but before doing this, one more thing that I want to mention is we are already in the GPU system. So we have the GPU resources allocated for us. So what I would do at this point is I would see if I have CUDA installed, because CUDA enables AI models to use your GPU. So let's see if CUDA is in the module. So module list. And you see CUDA is not being listed. So let's load CUDA into our environment. So module, you can also install CUDA if that's what you want, but I mean, they already have stable versions, so rather use it. So if you want to know all available CUDA, so the same command, spider, instead of SPI, it's SPYDER, and type just CUDA, and IPEC 11.8, which is like super stable one, and I've been using consistently. So module load CUDA. Now again, do module list to double check if it's loaded, and now it's loaded. So now when you say module load, it's actually adding CUDA into your path, the $path that I mentioned earlier. So all these dependencies are literally sitting in your path. So now you have your CUDA also in the path. So when you now go ahead and install, say, Ultralytics, it knows that it's using this CUDA, and Ultralytics will set its path. Like inside Ultralytics, it has to tell which CUDA to use, and it'll actually take this particular path of this particular installation and link to that when installing Ultralytics. So now let's do this. So the next thing is you use this. So yeah. So when you set this, you can set to, like, say 10, 12, whichever is available, and you can hit enter. But if it's not there, it'll throw an error. If the Python 3.10 12 version is not there, it'll throw an error. Otherwise, it'll smoothly run and you just say yes. And everything is being installed in your path directory here. So I think this will take a long time, but so I'll cut these short because I've already set up the environments. So once the environment is ready, you simply say conda activate the environment and which pip. And since I've done this already, I'll quickly go over that installation. Yeah. So let me open my notes text editor. So I already have the installations done in this particular path. So now I'll be activating this path here. So instead of using $pwd, maybe use an environment variable, because let's say you are in another project or scratch space and you still want to use your project space miniconda. If you have an environment variable like this, it'll be really useful. So now I have this set up, and if you actually see what environments are available in the current path, you can simply type conda info environments. And since I'm already sourcing it to this particular conda, I will only see environments that are inside this environment. For instance, like here, I still use the same name, but if I use something like say YOLO 11 CMD, I won't be able to see it within this environment because that is like super central to this particular environment. But I think here I would still be seeing, yeah, demo. See, you see all the environments in this listing. But these are the ones that you load and you source. So now, since I'm in my login node and this installation is done, I'll still not use it. So I'll still use the Pizzer node to give some examples in the future. But let's go here. And yeah, these are the different environments that I'm using. So what was the next task? Yeah, which pip, like this is a test to see if you have successfully, installed or set up the environment. So if you simply say which pip, it should be showing the exact path. If the path is wrong, it means that your conda is not sourced correctly to whichever folder you want. So here you see which pip. Oh, didn't get copy pasted. Nice. Which pip, if you just type that, here you see you are inside demo. Whereas here, these two in terminals literally are sourced to different conda paths. So you see the different environments here. So once now you have set up the environment, you have done the required installations. I think in the coming weeks, we'll just follow the version of Ultralytics. So if everybody could actually get or set up their code with Ultralytics following this environment setup guide, it'll be great. So we'll install Ultralytics, and now I've already installed Ultralytics and I have a sample code that I created, which is called test setup.py. And let me quickly show you what that file looks like. So once you have, like say, installed Ultralytics, and if you go to their website, they'll actually tell you what available you have installed it either manually or directly. And you actually go to their website and they'll give you a piece of code. You can simply copy paste. For instance, this is the piece of code that I've copy pasted. And if you run it, it'll tell you whether your installation is successful and your testing, all the setup that is needed for you to train your models is ready. So that's what we are currently trying to do. So in my project space here, and I see, yeah. So here I see test setup.py. And one more thing. So I was saying, right, you can use on demand for multiple things. When you do edit, you're literally in a file edit mode. You have cool, fancy ways of editing your text file as if it's your notepad. We will be using notepads like this here. I'm using Sublime Text, and I think if you're on Windows, you'll use Notepad++ and whatnot. This gives you the same feel, and on-demand people constantly would be upgrading their user interfaces. So you could use this, and here, there's a very simple Ultralytics model, which is basically loading a YOLO 11 model, and it's trying to train that model with Coco 8 YAML dataset, which is basically a very tiny dataset that they took for 3 epochs. And then it's validating against its validation dataset, reporting it, and it's testing it. So it's basically downloading a bus image and testing how this model works. And here the model is being exported to Onyx, which you can have multiple ways. And this is AI thing we'll discuss when we reach there and if it's needed based on your requirements. But basically, this is one way to see if my Ultralytics is installed correctly. So with this experiment, as I said, I have 3 environments that I've created: YOLO CMD, CUDA, and CUDA NV. You could use the CMD version if you're, I have, so when I installed _CMD, I was not inside a GPU node. So if I run, let's say if I request a CPU instance and I load this environment and try to run it, since CUDA and all the dependencies are not loaded, your system would still run in CPU mode. But when you install CUDA, this one, it will run in GPU mode, and we'll see if that is true now quickly. So here, remember, we have 2 environments that we set up. One is CMD and one is CMD _ CUDA. So let me change my source path and let's see. Since I haven't activated any environment, I'm still in the base environment inside my actual installation. Let me go back and load one of the environments after sourcing things. So I'm exporting. So basically, I'm sourcing it back to my non-demo, the previous mini Conda that I've already installed before the demo. And now I'm activating the command line version of it. And now let's run time command time Python test _ test. I have to go outside demo. So my folder is here. Yeah. So time Python test _ setup. So it's basically testing if my installation is perfect and everything. And I'm using the YOLO CMD version, which I believe I installed without loading CUDA or on a CPU node. I used login node to install this setup. So it takes time. It's loading things. Let's read what it is saying. I think it looks like yeah, CUDA 0, it's taking CUDA. So I think it did install. It did install CUDA, even if it didn't find it. But sometimes when you don't do it, you will literally see it saying CUDA not found and it can't run as efficiently. And sometimes they simply dump a CUDA version. I think here, if you see, what CUDA version is it showing? It's showing CUDA 12.4 because I didn't load any CUDA by myself. So it probably took its own CUDA version and it's running it. And we see it took like 59 seconds, like full. But now let's change Conda environment and say CUDA. So this one I used 11.8 in the environment while installing. So let's see if it took it. So now I changed my environment. So this is so quick. So I went from one environment to another environment and I'm rerunning my test setup here. And I hope I'm correct. So let's see. I mean, if you have any questions, please put down in the chat. So yeah. So here you see CUDA 11.8 because I have loaded CUDA 11.8 and installed Ultralytics. Whereas in this version, I didn't load any CUDA and I installed. And so since it didn't find any CUDA in path directory, it loaded the default or the latest stable version that Ultralytics downloads. And that is 12.4. So, and I smoothly transition. So I have 2 installations in the same. I'm not changing node. I am in the same node. I'm just changing from one environment to another. So it's like I'm changing from one room to another very quickly without having to redo anything because both my rooms are now set up and I'm running it. And here with the older version of CUDA, you see, it's almost the same. So multiple runs, you can't really tell in one run this is faster or slower. But that's the case. So now let's see what it takes when we are in the login mode. So here we are still in the base path. So let's go and see. Again, this is one of the experiments I'll show you since you can run. So, okay, Conda activate, I'm activating YOLO. And now let's go into the path. Where is this path? So you can use UI copy path. So it copies this entire path for you quickly. So using on demand is very efficient, same as using Visual Studio, for instance. And I'll give you a tip of Visual Studio in just a while. So here I'll literally moved into this folder, and remember this is like a login node, so it's pure CPU. And now test it. Python. And we all know that, for at least all machine learning tasks, GPUs are super efficient. Test Python. Oh, not test, setup.py. Sometimes it throws a warning, especially if the environment is expecting a CUDA, and if it doesn't find a CUDA or a GPU, it'll throw a warning. But this literally run. So now let's shift into one of the final ways of using Python, which is more or less like most of us are used to using collab nodes, right? We use collab nodes because we can visualize things which you can't visualize, like say in the command line, it was generating results here, but you couldn't see it. And if you have to see it, all you have to do is you have to go back to your file system, go back to where your runs are, and literally go into your detect, open the latest detect. So let's say it ran this one. So open this and look at the result, PNG. Like, look, come here and see for the results. It's supposed to have labels. So here you come and see the results. You can't visualize everything in one window. So one more efficient way of visualizing things would be interactive apps. And one way to do it is you go to Jupyter, you click Jupyter. You have Jupyter Lab, whether you want an entire lab of notebooks or you just want one notebook, depending on that. Here I'm choosing Pizzer, the project, just 2 hours, any GPU. Make sure you select GPU if you want GPU. These first 3 options are if you want only CPU. Any will give you whatever is available immediately. It could be CPU or it could be with GPU or without GPU. But if you want GPUs for sure, just select any GPU and that should give you. And I believe large memory or huge memory are simple CPU nodes, so you'll not get GPUs. So make sure you select options with GPU. Then you have details here. You can read through the details here. And number of GPUs, 1 at this point, I'm not using more. And here you can select CUDA version. So when you select this CUDA version and you try to run environment, you should still be able to run the environment, which if I have time, I'll show you that. But number of cores and launch it. Again, this is same as how we did a S allocation. This is also an interactive mode where you can literally interact with the node using a collab node. It'll take a little while before we enter the lab mode. But let's come here and see. Yeah, it took 1 minute, 6 seconds. I mean, it took relatively longer because it's a simple test that we're doing and we are in the login mode. It'll be really efficient if you're not in the login node or know many people in the login node. So before it takes time, so I'll run over the remaining slides that I have. Another creative thing, I would say, another tip that I would give you guys is used to system links, and why I'll tell in a while once we get this allocation happen. Yeah, the allocation is done. So 1 node, 10 cores, and it's starting up. So basically here you see you got the allocation. So what they're doing is they're starting up the node for you, and they're literally setting up the Jupyter environment, all the code. Like, let's say if you know containers, how you load the containers. So similarly, they're setting up the entire Jupyter node and it's connected. So all you have to do is now connect to your Jupyter notebook. And you literally see a home environment. And this is literally your home directory. If you see, this is like your desktop documents you see. Again, one of the problems that you'll have, for instance, let's say you select any Python notebook here, it creates here. So it expects that you have all your code, all your images in home directory. And as I said, home directory is not an ideal place to put. So what I prefer to do is create a soft or system link. And this is literally the command for it. So what it does is it creates a nice soft link into your home directory. For instance, I have created, let me go back to on-demand files here. So here, this is literally my project space and I'm inside my project space. And I created a folder called my YOLO code. It literally sits, you see the path of this one, it literally sits here. But I can also see this path from my home directory. I'm inside my home directory, but I can see the same my YOLO code here. So if I enter this and let's say I change the name of this one to demo bus and hit enter. And if I come back here and I refresh this page, I'll see demo bus, but the path is different. So creating system links or soft links is really efficient when you want to use Jupyter notebooks, because they literally launch Jupyter Labs from your home directory. So you can only access everything here. And even if you try to change it, you can't go beyond this. You can go FSS and stuff, and that's super crazy, but this is one efficient way to navigate around your system. And the second thing is, so far you have seen how you set up code with Ultralytics and stuff, but if you want to run Jupyter Labs or any Jupyter notebook, you need a kernel inside your environment. So you need to do something more. You need to install another instance, which is called literally, are we here? Yeah. So you basically have to install IPY kernel to make your environment visible from the collab environment. So after you install, let's say after you have installed Ultralytics and everything, you could still use that environment for normal terminal interactions. But if you want to use a collab notes or any notebook environment, you have to set this up, and you just have to create a link for it. So I've done that. And for instance, here you see that I have, this is a alias that I gave. Let me launch this alias and show you. It will only list those environments that have that IP kernel in there. In this one, you will not see these environments that I've created. What were the environment names again? Yeah, YOLO underscore CMD. You don't see those environments here because they don't have the IPY kernel installed in them. But this is the environment that I created where I've installed that setup, and I select this. But again, as I said, once you select an environment from outside your local or outside your symlink, you're creating a new file in your home directory. So I would rather discourage that. So create a soft link to your project space. Go into that project, whatever is the soft link or symlink you have created, go there. And from here, you can create a new environment like YOLO GPU code. And you can really run things from here. So I've already created one here to show how it works. So now I have all the installations done. So when I run Ultralytics here, oops, I have to load. So here you see it's showing Python 3 IP kernel, which is a different kernel environment. So let's say you accidentally created a notebook here. You can still go back and select the kernel that you want that has your installations and everything done. So here, where is that kernel? Let's close this, discard. Let's disconnect this kernel, delete. Yeah, so go back here and see if you can locate that. Where did it go? This is interesting. Yeah, let's copy paste this. Now I'll close this. I'll create, so now I'm inside the kernel that I created. Usually where it shows, your kernel shows up here, preferred kernel. You just select whichever environment you want, and you can switch between environments. And once that is there, you can run your code from the collab notes, and you can view results from here, and you can do many things from here. As opposed to command line, here you can literally see results. Like I think, let me see, I think I have. Yeah, it's still running and it's done. So now you can do runs here, detect here, and click your predict model like bus. So you can see the results here. And all in one tab, you can run. You can feel as if this is your collab notes without having to connect to Google Drive. Because when you use collab notes, you have to connect things to Google Drive. But here, you're literally using your OSU space. You're not going outside your OSC space, and you're still getting the benefits of using a notebook. And finally, the same things you could do from command line here too. So you're here in the command line and you type ls, but here you might say, hey, now can I run the same notebook that I have here, that I showed you here, but from Visual Studio, and without having to create any new environments, you can still do it. But one more, I think I would call this tip 3 or tip 4, is like whenever you connect, like we did an SSH into this terminal, if you remember, we SSH into the Visual Studio, but then you don't see the file systems, right? You don't see all the files here unless it's terminal connected. So when you actually log in into any OSE systems or any supercomputing systems via Visual Studio, and when you say SSH, it connects you just into the login node. You don't see the file system. So you have to connect to your file system. So Visual Studio looks at your file system as if it's your local box. So how do we do it? We simply say open. And now it'll ask you which path. So I would say I would open FS, ESS, TS 2271. And say hit OK. So now it'll ask me to relog in if it doesn't remember. So since I already logged in, it's showing yes, but otherwise it'll ask you to enter your password again because it's trying to make another connection, or it's trying to establish another connection to the file system. And you say, yes, I trust the authors. So now you're connected. So doing SSH into the system will only take you to your login node, but you don't have file system access. So again, connect to your file system from the login node. You can't directly connect to a file system. So first do an SSH into the system, then go and select, hey, I want to open a file in this particular file system, and it'll open another window. If you see, this Explorer window is different than the previous Explorer window, which is your SSH. But now you can see the entire files on the left, which earlier you were unable to see. So I'll come here. I can still look at all my files. I can look at my demo folder. I can look at the YOLO code, the runs. I can look at the prediction, the bus image, everything. So now here I can visualize the bus. But now you can ask, hey, can I also run the code from here? Yes. So here you have your notebooks, the same notebook that we have tested earlier. And it's trying to same thing, like in UI, when you're using the Jupyter Labs, it's asking you to select a kernel, click on Python environments, and it should be able to see all the environments that you have created, all the environments that are there in your Conda environment on OSE. You can also see them from Visual Studio. And let's select YOLO. So this is the one that I have the IPY kernel installed. So now I've connected to this, and all I have to do is run. I'm doing nothing. So I have the same environment, but now I'm using my Visual Studio. I'm not using browser if I'm not comfortable. If we are more comfortable with Visual Studio, you can run the same things from here and it's running. And if you're like, say, hey, I don't want to use this one, but I rather want to use the command line option, all you have to do is go to terminal in the same window, and you're now connected via terminal through the file system. So now you can do ls and do the same things that you have done, and you can run your code from here. So you're still in your login node here. So remember that when you ran the code here, you're still running it from the login node. But if you want to run this code through, like, say, a remote SSH or a node, then instead of SSH ascend, you have to do SSH a0306.osc.edu, which is your login node, and then do the same operations. And in the next session, I'll show the time differences and how you can gain efficiencies by using different file systems and all these scenarios that we went over today. So again, I'm in this node and I'm actually inside like CD, Swathi, OSE, and let's say, yeah, I have my test setup here. I time Python test setup. You get this error, and this is supposed to happen because you are still in your base environment. So you have still not connected. Though you have connected this particular collab nodes to your kernel, this terminal is not connected because these are two independent connections that are made to your OSU systems. So the environment is not the same. So terminal, again, you have to do the login and do it. But otherwise, individually, if you want a collab notes, you can do everything that you have done on demand using one single Visual Studio browser. So whichever version you're comfortable, feel free to use it. And finally, yeah, so we have looked into how to set up kernels, where to set up code, and how to do the tips and stuff. Creates a symmetric link to use on demand. But if you're using Visual Studio, you don't need to create a soft link because you can literally connect to any folder, maybe a project space, home space, any folder, and you can directly run your notebooks here. So this is another efficient way to use notebooks if you don't want to use Jupyter Labs, which is connecting to your home directory, and you don't want to create soft links. So yeah, and also there are a bunch of readmes that I've put in here that you could see. Quick hands-on tips if you want. This will be in the next meeting. We will look at how if we let's say if I'm training a YOLO 5 model from by reading my images from home directory versus project directory versus a temp directory, how efficient my training could be, and what is a perfect way to train my model so I'm more efficient. So I'm not continually copy pasting my images from storage to my compute node and stuff like that. A couple of tips. So if you can quickly, if you have requested any resource access now, you can try these command lines, but quickly let's look at what tempdir is. So in my Visual Studio, for instance, this particular node here is login node. So if I literally say echo tempdir, it'll give me an empty directory. It's not giving me anything because that variable means nothing in my login node because it's a variable that is super specific to the compute node when I get an allocation. So here, this is my non-login node. So this is literally my allocation, which is P0231. So now let's do echo dollar, oops, go dollar mpdir, and you'll actually see this folder. So when you're actually running this node, the difference between the login node and here is this particular file path is no longer sitting in this particular folder. Here, that particular path is no longer here, but rather that path is inside the compute node. Let's say this is your compute node, that path is inside that compute node. So whenever you copy images, and it also has like maybe 1 TB or so, depending, you just have to read the documentation, but it has a huge space. So usually genomics people or whoever has huge IO that has to happen, what they do is they move their entire data into temp directory and then do their processing there. So now they're no longer moving from compute node, like they're no longer moving from here to constantly access files. So that's one thing that you could try if that's what you believe can accelerate your training job. And we'll see that in the next week. We'll time those, we'll see that. And we'll also probably look into distributed training and how to do that. So here we are in login node, and we already saw how it's different from login node. And the next variable that you could test is, home directory we have already seen. PSFDIR is again another folder, which is quite interesting if you're using distributed training. So for instance, let's say echo this. This is empty because in login node, it really doesn't make any sense. But when you are in an allocation that is like say doing distributed training and you have more than one, you're doing distributed training and you have more than, you ask for 4 nodes which have to access common data store, then you would actually use echo. You'll actually use this space. This one, if you look at the space now, earlier, the difference is here, this is temp and slurm temp, and this is your job ID, and it's inside, this one is literally sitting inside this node, whereas this space is sitting inside your scratch space with your subname. So it's literally not sitting in this space, but rather sitting here, but they write efficient IO. It has efficient IO. So let's say these 4 nodes want some data super fast, then you literally can copy paste that here in this particular folder. So they access it very fast, very quick. And we'll probably see the examples of how we'll use different storage spaces for different Ultralytics. I'll use Ultralytics as a guiding example, and we'll see how different trainings work and what are the what training speed ups could we get if we try to adapt to any of these tips and tricks. That's all for today. Any questions? If not, then I'll share the recording and I'll also share the PT files, and we will have the next session next Thursday this time, and I'll share what to-do list you have to do, like setting up environments and stuff you have to do before coming here so you can catch up on how we run with different environments and stuff.